Visual Designer includes motor control shields as standard, but you can also use the schematic as your breadboard and program your own. This movie shows one way to drive a DC motor with some simple electronics. We'll set up our circuit so that a button press will speed the motor up and a second button press will spin the motor back down. Let's start with a button. Since we are responding to a press, it's best to connect the button to an I/O line with a pin interrupt. We can then set the internal pull-up on this pin, which will allow us to connect the button directly to the line on the schematic. In Visual Designer, we set the pin configuration in the setup routine, along with the interrupt. This will be a falling edge trigger since the line will be pulled low when the button is pressed. Drag an event block onto the chart and set the event to handle the interrupt. Any blocks added to the routine will then be executed whenever the button is pressed. Now for the motor. We're going to use the Arduino analog write function and send a PWM signal out on the pin. However, we need more current to drive the motor than we get from the microcontroller, so we'll use a transistor and add a battery on the other side. First, let's pick what we need from the libraries. We have our protection diode, a battery, our motor, and a tip 120 transistor. Then we place and wire up. The base of the transistor goes through a current limiting resistor to the microcontroller pin. Remember to check the Arduino documentation, as you can only use the analog write function on specific pins. The motor connects to the collector and the emitter goes to the ground. Add the battery to power the motor. And the protection diode in parallel to the motor to block reverse voltage. Back in Visual Designer, we can now add the bulk of our program. We'll need a Boolean variable to decide whether to spin the motor faster or slower, and then a couple of loops in our interrupt event to control the motor. What we are actually doing with the analog write call is either stepping up or stepping down the duty cycle of the PWM signal to the motor to control its speed. A bigger value means that the PWM pulse is on for longer and that the motor will spin faster. You can see this in action by wiring a scope to the I/O line and monitoring the pulse train after pressing the button.